questions, I asked, how would you calculate the length of the sides of a triangle, right? And the ones that were up and down and left and right, those were easy. Like if I had a vertical line here, like this, you'd calculate the distance of it by doing what? By counting. Good. 1, 2, 3, 4, 5, 6. It's 6 long, and you'd find the midpoint by dividing by 2. You just take 6 divided by 2, 1, 2, 3, there's a midpoint. That works great for vertical and horizontal, but when you've got a tilted line, you can't do it that way, because if you remember back when you studied right triangles in Algebra 1 and you did Pythagorean theorem, remember the hypotenuse always has to be the longest side, right? And so if you think of this little square as a right triangle, that's the hypotenuse, and that is longer than this side or this side. So you can't, it's not 1, 2, 3, 4, 5, because those are longer than 1. All right, it's actually the square root of 2. I don't know if you want to add up. We can't actually add up square root of 2 because it's not it's a rounded number, so we can't really add them up. So we need another way to calculate the distance, and when they're slanted like this, to calculate the distance and the midpoint. Okay? And so what we do is we go to their actual ordered pairs that are on the endpoints and calculate the distance, kind of based still on Pythagorean theorem, but calculate the distance of between those 2 points, which happens to be the exact distance of that line. So first thing you have to do is figure out the ordered pair. So A is at negative 1, 2, 3, 4, 5, and then 1, 2, 7, 8. So it's at negative 5, 8. And B is at 1, 2, right? Does anybody know why they're called ordered pairs? Why do we call that an ordered pair? Yeah, because it's always in the same order, x then y, always, x then y. And later on, we're going to be studying three-dimensional graphing, and we're going to have x then y then z. And they're always going to be in that order, x, y, z. Okay? So we can count on these being the x's, these being the y's. And when I calculate a midpoint, when I try to find the middle here, I again need an x and a y. I need to know what that point is. So, so to do that, ordinarily, like you said, you just divide by 2. You count up and divide by 2. But when it's slanted, I need to find the x-coordinate that's in the middle and the y-coordinate in the middle. So I just do them one at a time. Rather than just count and divide by 2, I add up the x's and divide by 2, and I add up the y's and divide by 2. Does that make sense? Okay, so you can, if it helps, you can label this, like you can call this x1, y1, and this x2, y2 if you want. Y2. Or if you just remember, you don't have to label them, but if it helps you remember where they go. So x1 is negative 5. x2 is 1 divided by 2, and that's going to give me the middle between my x-coordinates. And then to find the middle between my y-coordinates, I add up my y's, 8 and 2, and I divide by 2. Then I just do the math. Negative 5 plus 1 is negative 4, and negative 4 divided by 2 is negative 2. 8 plus 2 is 10, divided by 2 is 5. So my midpoint is at negative 2, 5. So I go over here, negative 2, 1, 2, 3, 4, 5. There should be my midpoint. Does that look like about the midpoint? Does that make sense that it's in? One thing, I get tests back sometimes, and like they'll calculate the midpoint to be right there. What's wrong with that? Yeah, it's not on the line. It can't be the middle way between A and B if it's not even on the line, right? So be careful when you calculate it. If it's over here, you did something wrong. Go back and check. Okay? right, so you take a turn. Let's calculate the midpoint of CD. And for people in the back, can you, Brianna, can you just give me the coordinates here just so the people in the back don't have to try to see it?
Okay. -2. 0.
Down 1.
1.
-1. Yep. And this one?
5.
Actually, it's 4. Sorry. It's really hard to see, I guess. Right. 4 and 2 and -2 and -1. So take a second and calculate the midpoint. Now, so she took x1 plus x2 divided by 2 and got 1. Y1 plus y2 divided by 2 and got 1 half. Some people got 1, 1 and a half. Good. Okay. All right, so that's midpoint. Again, this formula is not on the green sheet. So if it doesn't make intrinsic sense, like if you couldn't generate it yourself, make sure you at least memorize it. All right, then the distance formula. The distance formula is based on the Pythagorean theorem. What was that again? Right, a squared plus b squared equals c squared. It's calculating the distance between a and b by kind of turning this a little bit into a right triangle. And so this would be this would be the c, the hypotenuse. So it's taking x2 minus x1 is the length of a squared, and then plus y2 plus y1, which is the length of b squared. So a squared plus b squared equals c squared. And how do you find c if you have c squared? Take the square root. So that's what the big square root is doing it. So this is all kind of based on the Pythagorean theorem. Okay? So again, remember this is -5, 8, and this is 1, 2. So I just need to plug the numbers in. So to find the length of going this way, I'm going to use the x's. So I do x2, which is 1, minus x1, which is -5 squared, plus, and to find the length of between on the y's, it's y2, which is, what did I start with? 1, so 2 minus 8 squared, all under the big giant square root, because that gives you square root. Yeah.
Since like one's kind of hot length, it just like cancel out and
Yeah, absolutely. Yeah, so 1 minus -5 is same as 1 plus 5, which is 6. So that gives me, still under the big square root, 6 squared. And then 2 minus 8 is -6. So I have -6 squared. So 6 squared is 36. And -6 squared? Oh, careful. Negative times a negative is a positive. So it's positive 36. Okay, so I have square root of 36 plus 36, which is the square root of 72. And remember, we just learned how to, or just remembered how to do this. You hopefully learned it last year. You break that down into 9 times 8, which is 3 times 3, 4 times 2, which is breaks down into 2 times 2. You got 2 pairs that stay outside the radical sign, and 1, 2 that doesn't have a partner, so it stays inside. Okay, so 3 times 2 is 6. 2 stays in. So the final answer, the exact answer is 6 square root of 2. Okay? So if you were going to continue on and do more calculations, you'd leave it as the exact answer like this. Like if you were doing calculations for NASA, you'd want to be exact. All right? But if you were going to the carpet store, you can't ask the guy in the carpet store to cut you 6 square root of 2 feet. They would look at you like, what? So in that case, like if you're actually going to have to measure it with a ruler, you would use the estimate, which is 6 times square root of 2 in your calculator. So it'd be 6, a decimal, so put a decimal around it. Yeah. Okay? So So, it should be more than 6, so.
It's 8.
Oh, 8, but yeah. So this is the exact answer, and that's generally the one we're going to use, but there's also the estimated answer where you actually just plug in your calculator.
So with this, when we figure it out, like 6 squares actually units.
Yeah, because we don't know what these squares are. All right, so take a second and try CD. Okay. How many people got 3 squared root of 5 or square root of 45? Good. Awesome. All right. All right, then the other way to look at this, and I wanted you to make sure you know how to do both of them because sometimes one of them is easier, like if there's a graph provided for you, it's kind of easier to use this method, the Pythagorean theorem. If all you have are the points, it's kind of easier to use the distance formula. So I want you to know how to use both of them so that you can always pick the easiest way and you're struggling to do it. So the idea behind calculating the distance with the Pythagorean theorem is that if I'm looking for the distance of AB here, I'm going to turn that, like to pretend like these aren't here and you just have segment AB. I'm going to turn that into a right triangle by just coming straight down and straight across till it makes a right triangle. Okay? Then, because these are up and down and left and right, I can just count them, right? I don't have to do any calculating. So this one is 1, 2, 3, 4, 5 long, and this is 1, 2, 3, 4, 5, 6. And now I can just use Pythagorean theorem and do 5 squared plus 6 squared equals c squared. So 25 plus 36 equals c squared. 61 equals c squared. And c is equal to square root of 61. Can I reduce that? I don't think so. 61, yeah, I don't think anything goes into that. Does that make sense? So take a second and go back to AB here and calculate, using Pythagorean theorem, calculate the distance from A to B, and then what did you get as an answer? 6 squared root of 2. Like, it shouldn't change the answer the way you do it. All right, so 6 squared plus 6 squared equals c squared. 6 plus 6, and then reduce it, take the square root. All right. Your homework is